Alright, in our last page, we're going to find the angle such that its cosecant is negative 1.604 and it's between 630 degrees and 720 degrees. So it's gone around the unit circle a few times here. It's gone a few rotations. Okay, so first, let's go ahead and find the angle. Okay, so the angle is going to be the arc cosecant of negative 1.064. Now, I cannot do arc cosecant in a calculator, but I can do it on Desmos. So we're going to take advantage of that. Switching over to Desmos, there we go. So in functions, I can do the arc cosecant of negative 1.064. Big advantage to being able to use Desmos over just the calculators where I can't do that. Now, if the button is not available, you can type arc cosecant and do the same thing from there. Negative 1.064, you got it. Okay, so this is not my theta. This is a phi that is a reference angle for theta. It's negative 70.0263. Okay, so I'm going to flip back to my screen here. And so I'm going to draw myself a little picture now of what this angle looks like. I didn't know what quadrant it was in. I could have figured out what that meant. But first, now that it's a negative 70, I know that my angle is in quadrant 4 because negative 70 is less than negative 90. It's in quadrant 4 about negative 70.0263 degrees. All right. Now, the angle that I actually want for theta is going to be, if I go around once, that's 360 degrees. If I go around twice, that's 720 degrees. So I want to have this angle go around almost twice. So I'm going to take 360 plus 360 to get all the way around twice, and then I'm going to subtract off the 0.263. So 360 plus 360 is 720. So I can take 720 minus 70.0263 to get the angle for theta. So the angle for theta is 649.9737 or 649.97 degrees. Usually we can keep two places on angles unless we're told specifically that we need more. Okay, just want to check it. So I'm going to go back over to my Desmos window and we're going to check that the cosecant of 649.97 degrees is about negative 1.064. And again, with rounding, you can round that to negative 1.064. So we have the correct angle in the right interval. It's between 630 and 720. Okay, so there we go. All right, in example 8, hopping in your Cessna, you can fly at a speed of 110 kilometers per hour for 3.2 hours at a bearing of 319 degrees from Jackson. How far north of Jackson's latitude are you at this point? Okay, so bearings, remember, I'm going to put Jackson right here. Bearings are computed from north. This is not a traditional measure. Traditional measures count from the x-axis, which would be east. I'm counting from north, and we're actually going the other direction. This is how compasses work. It's not the same thing as how we usually measure angles, so keep that in mind. Bearing. They go, I'm going to refer back to my previous page just for confirmation. Here we are. Remember, bearing is measured clockwise from north. So much different than the traditional measurement, which measures counterclockwise from the x-axis. So clockwise from north, this would be clockwise from north. That would be 180, 270, 319. that's 319. So in order to be able to work some trigonometry on here, I need to figure out what the reference angle is. So the reference angle is going to be this angle right here. Okay, so I've had to go from 319 270 degrees and then past. So I'm going to take 319 and subtract 270 degrees to figure out how far I went past it. 270, because 90, 90, 90 is 270, right? I went 90, 180, 270, and then I went beyond it. So if I take 319 minus 270, that comes up with 49. So this reference angle is going to be 49 degrees, and we can draw ourselves that reference triangle. Okay, so the airplane's over here now, and it was flying at a speed of 110 kilometers per hour for 3 hours. So the distance that it flew diagonally will be 110 kilometers per hour times 3.2 hours is, I'm just going to multiply 110 by 3.2, gives me 352 kilometers. That is our diagonal distance, 352 kilometers. The question is, how far north of Jackson are you? How far north of Jackson are you is going to be the y coordinate, strictly how far up. Not how far over did we go, how far west, just how far up. So I'm going to be looking for this y coordinate. With this reference angle and the knowledge of the hypotenuse, I can find that using sine for opposite over hypotenuse. So I know that the sine of the reference angle, 49 degrees, is going to be equal to the ratio of y divided by 352. Okay, so I can multiply 352 times the sine of 49 degrees to get y. I can do this in my calculator or decimals. I have my calculator handy. So 352 times the sine of 49 degrees gives me 265.66 kilometers for y. All right? So after 3.2 hours, the plane, or the Cessna, is 265.66 kilometers north of Jackson. It's not directly north, of course, but that's the measurement in the north direction. Now, if you want to know how many miles east, of course you could calculate that as well using cosine instead of sine, and you'd be able to find the x distance and find out how far, I meant to say west. West is over here, east is over there. How far west is it also? There we go.